There are telescopes searching the skies for signals, for hints, for a sign of civilizations, or even the signals from starships moving through the sky.
3 short decades ago, our knowledge of the cosmos was severely limited. So much so that we had no concrete proof of the existence of celestial bodies beyond our own solar system. It was as if we were explorers staring into an enigmatic abyss, unsure of what lay beyond our own celestial backyard. Fast forward to the present day, and our cosmic understanding has taken an exponential leap forward. This surge is thanks to breathtaking leaps in technology and humanity's never-ending thirst to solve the mysteries of the universe. Now, imagine we found more than 5,300 exoplanets. Now, if you're scratching your head wondering what an exoplanet is, let me simplify that. An exoplanet is a planet that's not part of our solar system. To put it more simply, these are planets that orbit around stars other than our sun. It's like living in a city your whole life and finding out there are thousands more cities around the world. So, these exoplanets are like alien worlds, hiding in the wide, open spaces of the universe, biding their time, waiting for us to discover them. Isn't that a bit mind-boggling? More than 5,300 alien worlds are out there, deep in the cosmos, just waiting for us. They're like the universe's little secrets, cloaked in the shadowy fabric of space and time, ready to be unveiled and deciphered. With each passing day, our cosmic roadmap expands, and the universe becomes a little less unknown. That's the power of our unquenchable curiosity, and fueled by technology's relentless march forward, it's only a matter of time until the hidden secrets of these exoplanets come to light. Early on, our discovery tools could only capture gas giants, the colossal celestial beings, much like our very own Jupiter and Saturn. But as our technology evolved, so did our reach. Now we've laid eyes on planets bearing an uncanny resemblance to our home, Earth. Over 800 such planets have been found with sizes not much larger than Earth's, and more than 50 carry similar masses. However, finding planets is one thing, finding ones that might support life as we know it is another. Life as we understand it relies on a delicate balance, necessitating specific conditions. Such planets must orbit their stars in the habitable or Goldilocks zone when conditions are just right, not too hot, not too cold. Despite the challenge, we've started making strides. Several planetary systems have been found housing multiple potentially habitable worlds. Even within the cosmic neighborhood of our Milky Way galaxy, we've detected a promising system. Our galaxy is teeming with star systems strikingly similar to our Sun. But planets orbiting too close to these scorching bodies are generally too hot for life. However, for cooler, dimmer stars, the life-sustaining Goldilocks zone is much closer. Lying in the constellation of Scorpius, a mere 23 light-years from Earth, is the fascinating Gliese 667 system, our very own cosmic triad. This is the first system ever discovered with multiple rocky planets in the habitable zone of the low-mass star, an unexpected oasis in the cosmic desert. In this system, the largest star, GJ667a, is an orange-red dwarf, a mere fraction of our Sun's size, mass, and light emitted. Its sibling GJ667b resides roughly 12.5 astronomical units away, and shares similar characteristics. But as with any gripping tale, the third, less obvious character intrigues us the most. Gliese 667c, the smallest of the trio, is a red dwarf. It's a chilly celestial body with a surface temperature substantially cooler than our Sun, and its faint luminosity is a mere whisper in the cosmic expanse. Yet, against all odds, this dim, small star boasts a rich and dynamic planetary system. Researchers have uncovered an astonishing fact after scrupulous study and reanalysis of existing data. There could be as many as 6 planets in orbit around Gliese 667c, with a stunning 3 or 4 of them being super-Earths, a tantalizing prospect for the existence of life. You might be a little bit curious about what a super-Earth is. Well, it's a planet bigger than our Earth, but not as big as the massive gas giants like Jupiter and Saturn. These planets could be mostly made of rocks, or a mix of rocks and ice. And they might just have an atmosphere that's good for supporting life. The closest of these, Gliese 667cb, is a scorching world with an average temperature of 200 degrees Celsius, making it too hot for life as we understand it. However, its substantial mass, 5.5 times that of Earth, suggests a thick atmosphere, further adding to its enigmatic nature. As we continue peering into the cosmic unknown, each revelation carries us further into an unprecedented era of discovery, inching us closer to answering the fundamental question: are we alone in this boundless universe? In a distant celestial ballet within the Gliese 667 system, 3 planets reminiscent of our own Earth pirouette gracefully, each a gem in its own right. They parade at various intervals from their host star, their mass fluctuating between 1 and 5 times that of our blue planet. Amongst these intriguing celestial bodies, one captures our imagination particularly: the enigmatic Gliese 667cc. This mesmerizing globe, lying on the brink of the habitable zone around its nurturing star, carries out a complete orbit in a swift 28 Earth days. Its mass is colossal, nearly 3.8 times that of our planet. But what sets this globe apart, earning it the reverential moniker of the Holy Grail of exoplanets, is an astonishingly high Earth similarity index of 0.85. The host star, GJ667c, a red dwarf, emits energy at a relaxed pace, making its hospitable zone cozy and close within a narrow space of 0.11 AU to 0.23 AU. This makes GJ667c's habitable zone fully nestled within the trajectory of our solar system's innermost planet, Mercury. To provide a contrast, our Earth orbits the Sun at a comfortable distance of approximately 1 astronomical unit. Earth, placed the same distance from GJ667c as it is from the Sun, would transform it into an icy, inhospitable globe. Gliese 667cc moves around the star 8 times nearer than our Earth moves around the Sun. Imagine it like this: if the Earth's trip around the Sun is like a running marathon, Gliese 667's journey is just a short sprint, finishing in 28 days. It's a pretty quick year, right? And you know what else? This planet is close to its star, just 0.12 astronomical units away. Now you might be wondering, what's an astronomical unit? Well, let me break it down for you. It's an astronomical unit, or AU for short, is basically a ruler that we use to measure distances in space. Specifically, 1 astronomical unit is the average distance from the Earth to the Sun, about 93 million miles, or 150 million kilometers. To make it simpler, imagine if you were to drive your car at 60 miles per hour, non-stop without any brakes. That would take you 177 years to cover 1 astronomical unit. That is 2 human lifetimes, give or take. Going back to Gliese 667cc, when we say that it's 0.12 astronomical units away from its star, that's 1/10 of the distance from the Earth to the Sun. That's like going on a road trip from New York to Philadelphia instead of driving across the entirety of the US. The intriguing configuration of Gliese 667cc results in it being tidally locked. In this characteristic, one side of the planet continually basks in the star's warmth, while the other remains shrouded in perpetual darkness. This unusual setup substantially influences the exoplanet's overall climate, leading to dramatic temperature variations between the two halves. Gliese 667cc bathes in sunlight at a level about 10% less than Earth's, yet it somehow manages to maintain an Earth-like climate, which this seemingly paradoxical phenomenon arises due to the predominant form of solar energy that it receives, infrared, allowing water retention on its surface. Imagine standing on the edge of a new frontier, looking into the vast cosmic expanse and finding yourself staring at a riddle cloaked in stardust, an enigma with an almost poetic charm. This conundrum lies at the heart of the alien world called Gliese 667cc, its surface shrouded in a maelstrom of unsolved questions and uncharted mysteries. Its exact surface temperature is a mind-bending puzzle that we're not yet to decode. It's like trying to guess the warmth of a bonfire from miles away, with only embers visible. The presence, or lack thereof, of an atmosphere around Gliese 667cc complicates the equation. It's akin to wondering whether a bonfire is in an open field or inside of a cave. Does it have a shielding blanket of air around it, like our own blue marble Earth does? And if it does, what's the thickness of that airy envelope? These tantalizing variables are still beyond our reach, and they lay like keys thrown into an abyss. However, let's engage our imaginations for a moment and envision a scenario where this enigmatic exoplanet does possess an Earth-like atmosphere. Let's paint a picture in our minds of a world that boasts evenly distributed temperatures, a planet that, despite its foreign surroundings, could have a familiar touch to it. On the dark side of this world, temperatures might hover cozily around 30 degrees Celsius, equivalent to a warm summer day in Miami. You could walk around in a t-shirt, feeling the alien breeze against your skin. This celestial body's illumination would come from a muted star, splashing Gliese 667cc's landscape with a uniquely reddish palette. Imagine standing on the planet's surface, witnessing an unearthly sunset, where the sky doesn't blaze with orange and purple, but throbs with crimson waves, painting an entirely alien canvas. It's like an artist who chooses a bold, unprecedented hue and transforms a familiar image into something utterly mesmerizing. Not too far away, at a cosmic distance of approximately 230 times the distance from the Earth to the Sun, not too far away. The other two celestial companions of the system, Gliese 667a and b, majestically hang in the inky blackness. At night, they would shimmer with the brilliance of our full moon, transforming the alien sky into a theatrical display of light and shadows. And when the day comes, they would shine like a pair of radiant celestial twins, inseparable and awe-inspiring. From Gliese 667cc, our own sun, the provider of life and energy to Earth, would be a mere flickering star in the far-off tapestry of the cosmos. It would glow akin to viewing a lighthouse from miles away, a faint but a persistent glow amidst the eternal sea of stars, a humbling reminder of our place in the grand theater of the universe. However, living in this alien realm could come with potential hazards. One of them would be solar flares, comparable to giant space-fueled fireworks with a deadly edge. Imagine the biggest firecracker you've ever seen on Earth, and then amplify that by 1,000-fold. These are monstrous bursts of radiation and high-energy particles spewing out of the nearby red dwarf, capable of dwarfing even the most powerful flares that our sun could produce. These cosmic outbursts are not the only variable in this life equation. The red dwarf, while being a cosmic lighthouse for Gliese 667cc, is also prone to creating star spots, akin to terrestrial freckles but on a stellar scale. These spots can lead to a dramatic decrease in the star's energy output by up to 40%. Imagine a heart with an irregular heartbeat, sometimes throbbing with vitality but other times faint and weak. Furthermore, the planet's position in relation to its star means a lack of ultraviolet light. It's like living in a world without the UV spectrum. Could you fathom a world where UV lights, a significant component in our planet's sunlight, are absent? Such a world would have a drastically different life prospecting equation. Gliese 667cc is a universe of uncertainty, a universe of potential, a world that might be simultaneously hostile and hospitable, with realities that could starkly be alien, yet faintly familiar. It's an emblem of our ceaseless quest to decode the cosmos and an embodiment of the awe-inspiring unknowns that make us wonder, explore, and dream. Life on Gliese 667cc, if it exists, would look vastly different from ours. The planet's immense mass dictates its gravitational acceleration, which is almost 60% more than Earth's. A human weighing 75 kilograms on Earth could easily tip the scales at a whopping 120 kilograms on Gliese 667cc. The gravity and the mass of this planet could have another fascinating implication. That could result in a far denser atmosphere than ours. If the exoplanet's atmosphere is similar to Venus, the atmospheric pressure could rival the crushing pressure deep within the Earth's oceans. Gliese 667cc may not be Earth's twin, despite its location within the habitable zone. Adapting to its potentially dense atmosphere, frequent flares, and irregular dim light would be a challenge. However, we shouldn't rule out the possibility here. The resilience and the adaptability of life, as observed on Earth, reminds us of the incredible capacity of living things to thrive in the most unexpected of places. Gliese 667ce and Gliese 667cf are like alien twins to our home planet. Each of these extraterrestrial marvels weighs in at roughly 2.7 times the mass of Earth, and is more massive still, with the latter boasting an impressive radius that stretches 1.45 times that of Earth's own. However, the most fascinating things about these cosmic twins is their orbit, situated farther away from their parent star, Gliese 667c. The distance comes with a notable cost. It means that they receive less solar energy, turning their picturesque landscapes into potential Arctic wastelands. Yet all is not lost for these seemingly inhospitable planets. Imagine an atmospheric blanket woven thick and full enough to trap in all the precious warmth. A heat haven capable of maintaining a balance in temperature. Like a snug winter coat. If these planets could foster a dense enough atmosphere, they could perhaps keep their surface temperature within life-sustaining levels. Unraveling the secrets of these planets is much like trying to solve a cosmic jigsaw puzzle. To find even one Earth-like planet comfortably snuggled within a star system's habitable zone is rare. To find 3 is extraordinary, and 4 is just unthinkable. Yet there is a tantalizing theory that all 5 planets in the Gliese 667c system may be potentially habitable, bathing in solar radiation that ranges from 20 to 100% of what we currently experience on Earth. Oh boy, this concept is as intriguing as it is complex. The habitable zones around the star, Gliese 667c, is not a solid line drawn in the cosmic sands. Instead, it's arranged, bordered by 2 delicately balanced lines, defined by the masterminds of astronomy. Imagine a region extending from 0.095 to 0.126 AU away from the star, stretching outward to a vast distance between 0.241 to 2.251 AU. Any celestial body swaying in a cosmic dance within these orbital confines could theoretically sustain liquid water on its surface, making it a potential cradle for life. But space is a stage of extremes, and being too close to the star can spell disaster. The intense heat could cause any surface water to evaporate, turning the planet into a dry and barren wasteland. In its gaseous state, water vapor acts like a potent greenhouse gas, trapping radiation and dialing up the thermostat to dangerously high levels. The only planets that could possibly weather such a damp greenhouse effect are those with massive ones that orbit the very inner edge of the habitable zone. Yet venture too far from the warmth of the star and another peril awaits. A planet like Gliese 667G, situated in the outer realms of the system, could become a frozen fortress, imprisoned within an eternal winter due to its meager share of solar warmth. One might argue that greenhouse gases, such as carbon dioxide, could save the day. Indeed, carbon dioxide has a warming effect that could prevent a planet from turning into a gigantic ice cube. However, it's a double-edged sword. An abundance of this gas would reflect more light than it absorbs, causing the planet to cool instead of warm. Hence, a delicate balance, a Goldilocks amount of CO2, could potentially aid in warming these enigmatic celestial bodies. Picture the year 2013, a memorable moment in the annals of space exploration when astronomers made an astonishing announcement. The star system Gliese 667c is a bustling cosmic neighborhood of at least 6 planets. A potential 7th, dubbed GJ667CH, also whispered its secrets from the distant cosmic darkness. Nestled between the orbits of planets C and B, this mysterious exoplanet boasts a mass slightly heavier than Earth at 1.1 times our planet's weight. Its existence, though, is a point of heated debate amongst stargazers. Planet H is a celestial heavyweight, its heft coupled with its proximity to the parent star, and that paints a scorching picture, making it unlikely for liquid water to exist on its surface. Yet, amidst this stellar uncertainty, planets F and E offer a glimmer of hope, twirling elegantly within the star's habitable zone. Planet D, an elusive cosmic dancer, remains shrouded in mystery, its orbit an unresolved question. However, its location beyond the habitable zone's outer reaches is a certainty, that much is at least certain. This astounding cosmic tableau hints at a thrilling prospect. Gliese 667cc, CF, CE, and even CD might be celestial havens capable of supporting life. The story of Gliese 667c suggests an even more exciting possibility. It is but one of the numerous M-dwarf stars that harbor tightly packed planetary systems, hinting at the potential existence of many more habitable worlds. Given that M-dwarfs can constitute a whopping 70% of all the stars in our local cosmic neighborhood, a multitude of promising planetary systems may surround us, many more than we ever dared to dream. With this discovery, the search for Earth 2.0, our potential cosmic twin, enters a new era. Astronomers can now focus their lens on individual stars, seeking out entire families of habitable worlds rather than painstakingly combing through 10 stars to find a single potential home. Our capacity to unravel the mysteries of the universe grows at an exponential rate, fueled by increasingly advanced telescopes that serves as our eyes to the cosmos, and just technology advancing in every single sector that is possible. All of it. So, where should we cast our gaze next? Which distant star system should we venture in through our cosmic discussions? Let us know in the comment section down below, and don't forget to hit that like button and subscribe for more. Okay, bye.